Here are solutions to homework set number 1 for ECE 341 random processes. This homework set looks at enumeration, basically brute force. If I can sit there and list every possible outcome, count the number of its successes, then the probability is number of successes divided by the total number of possibilities. Not much finesse, but just brute force. The first problem looks at a tree diagram. One way to enumerate all possibilities is to just kind of draw them out. For example, if I flip a coin, or two teams play a game, either A wins or B wins. If it's the first team to win by 3 games, you can sit there and write out all possibilities. Now, if I start with B having 1 point, those are the odds, then either A wins or B wins. If A wins, then the next game either A wins or B wins, and you keep on going until one team gets to 3. Once you get to 3 points, the match is over. So here A wins, B wins, B wins, B wins. So that's a tree diagram. It quickly gets out of hand if you have more than 2 possibilities or you get much further than 3 or 4. But for some problems, tree diagrams work really well. Problem 2. If I roll a 4-sided die, 6-sided die, and take the difference, I can calculate the odds of getting each number through enumeration as well. So if I roll a 4-sided die, I have 4 possibilities. I roll a 6-sided die, I have 6 possibilities. Altogether, we've got 24. Taking the difference in the two numbers, I get x is 0, 1, 2, 3, and so on, and count. To find the probability of getting 0 points, I just count. There's 1, 2, 3, 4 ways to get 0 points out of 24. So that's the odds of getting 0 points. For 1, there's 1, 2, 3, 4, 5, 6, 7 ways to get 1, and so on. So here's the probability of getting points between 0 and 5. And brute force, not a lot of finesse, just grind it out. Problem 3 looks at a conditional probability. So here's the chance of A getting points between 0 and 5. Suppose B gets 3 points. What's the chance that A wins, given that A wins on ties? Well, if B gets 3 points, A has to roll 3, 4, or 5. So adding all these up, that'll be the chance that A wins. So this is 7 out of 24. That'll be the probability that A wins. So that's the probability of A given B. And once I know B, it changes the odds. One of the big uses of conditional probability is you can take a harder problem, such as B rolls a 6-sided die, subtracts 1. A rolls a 4-sided, 6-sided die, takes the difference. Highest score wins. A wins on ties. What's the chance A is going to win? Well, this is one I don't really want to do enumeration because there are 24 times 6, 144 possibilities. That's a lot to write out. But what I can do is conditional probability. Split this up into 6 problems. B is going to roll a 0 or a 5. What's the probability that A wins, given that B rolled a 0, times the probability that B rolled a 0, plus the probability that A wins, given B rolled a 1, times the probability that B rolled a 1, and so on. So this is another way to calculate it using conditional probabilities. Well, if B rolls a 0, it gets 0 points, A guaranteed wins. Probability that B rolled a 0 was 1 in 6. If B rolled a 1, that's 1 in 6 odds. A can roll anything between 1 and 5. Gives you 20 and 24. 2, 3, 4, 5. Add them all up. There is 68 out of 144 ways that A wins for a 47% chance. So there's a 47% chance that A wins. Okay, Farkle. Farkle is a game you play with 6 dice. I roll 6 dice and get different combinations. Different combinations have different point values. 2 triples, I think, is worth 1,500 points. What are the odds of rolling 2 triples? Well, one way to do that, well, that's 5. Problem 6, what's the probability of rolling 2 pair? And this one, this can't be ZZ. If you do that, that's 3 triples, or 3 pair, that's a different point value. So 2 pair, I've got X, Y, A, and B. Well, I can do that using enumeration. This is just raw power. I'm going to go through every possibility. So the first die can be 1 through 6, second die 1 through 6, and so on. So this will go through every possible combination of 6 dice, which is 6 to the 6th different combinations. To determine what the value is, I'm going to take the dice and sort them, and then count how many 1s, how many 2s, how many 3s, how many 4s, and so on. Take n and sort it largest to smallest, so that tells me the highest frequency, next highest frequency, and so on. If the highest frequency is a 6, I have 6 of a kind. If it's a 5, I have 5 of a kind. If it's 4 and 2, I have 4 of a kind, 2 of a kind. If it's 4 of a kind, and so on. For 3 and 3, there it is. Here's 3 and 3. 2 triples and 2 pair. So the highest frequency is 2, next highest frequency is 2, third highest frequency is less than 2. That's a 2 pair. Grind it all out, and I get 300 ways to get 2 triples, 16,200 ways to get 2 of a kind. Total number of rolls, that's 6 to the 6th. So that's the odds of rolling 2 triples, the odds of rolling 2 pair. Now this is the beauty of enumeration. I don't need to know anything about combinatorics to find the answer. I'm just going to use MATLAB and raw power and grind it out. So this actually wasn't too bad. I think this took me like about 50 milliseconds to run on my computer. Harder problem. Oh, before we go to the harder problem, this is grinding it out in MATLAB. I'm missing a semicolon somewhere. So when I run this, this goes through every combination of 2 6-sided dice. That took me 1 second. So again, that's not a big deal. Sometimes enumeration works really, really well. This is a problem where enumeration struggles a little bit. If I have 6-card poker, I take a 52-card deck and deal out 6 cards. What's the chance of getting a full house? So I've got 3 of a kind and 2 of a kind. Could also be 2 triples. So I'm going to throw out 1 card. Both of these give me full house. Well, I can do that with enumeration as well. Well, that's number 7. Number 8, probability of 3 of a kind. So A, B, and C have to be different. In MATLAB, I can do that. Kind of what I do is I've got a 52-card deck. So the first card is anything between 1 and 52. Actually, 47 because I have 5 other cards. Doesn't really make any difference. I could make that 52. But anyway, pick the first card. The second card has to be different than the first one. And if I do C1, 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 I could have 5 ace of spades. And you can't do that. So C1 plus 1, C2 plus 1, C3 plus 1, and so on. At this point, I'm gone through every possible combination of 6 cards. I then find the value of each card. So this is going to be number 1 through 52. The number mod 13 plus 1 is the value, 1 through 13, ace through king. The suit, I don't care about. Find out what's the frequency. How many aces, how many 2s, how many 3s, then sort. If the highest frequency was 3 of a kind and the second highest was at least 2, that's a full house. If the highest frequency was 3 of a kind and the next highest frequency was 1, that's 3 of a kind. And. Then when you're done, print out how many full houses, how many 3 of a kinds. This is a little bit harder. I can do it using enumeration. On my XP computer, it took 33 minutes. Let this run. This is just displaying as I go through it. I'm currently looking at the first card in the deck, the ace of clubs. Going through every combination. This takes a while. This is kind of where enumeration, it sort of works, but it takes a while. Doing that after 50 minutes, I got an answer. And it's 50 minutes on an XP computer. I'm kind of jealous. Apparently, some of you have faster computers than I have. A couple of people got it done in 1 minute. But anyway, grinding through it, I can count how many full houses there are, how many 3 of a kinds there are, how many total hands there are, and that's the odds. Probability of a full house is just the ratio. There's this many full houses, total number of hands, 0.8%. This many 3 of a kinds, total hands, 3.5%. So that's the enumeration. And kind of see it works. Sometimes it works really, really well. Sometimes it really struggles. Like this last problem, I'm done when this reaches 47. It's taken some time. We need a better tool. Well, that better tool is lecture number 2 and homework set number 2, combinatorics. But we'll do that on the next homework set. So that's homework set number 1 for 341 random processes.